Hello, this is Swapnil Dongre from IIP's DAV Indore. Today in this video I will tell you about the NAT concept, that is a method that is used in numerical analysis and design to find the solution of set of n number of equations. This method is basically a Gauss elimination method. Here on your screen you see there are n number of equations, and what we have to do, we have to determine the values of x1, x2 up to xn by eliminating some terms and forming a lower triangle, that is triangularization is known as Gauss elimination method. So how this method works, for this illustration, let's take an example. Here we have three equations: a11x1 plus a12x2 plus a13x3 equal to a14, a21x1 plus a22x2 plus a23x3 equal to a24, a31x1 plus a32x2 plus a33x3 equal to a34. We are making places of a21x1, a31x1 and a32x2 as 0, and thus forming a lower triangular of 0, and that this is known as a triangularization, and this is basically a basis of Gauss elimination method. So how this triangulation can be done? There is an algorithm for it. Let's look at it. Algorithm is as follows: for I equal to 1 to n in steps of 1 and j equal to 1 to n plus 1 in steps of 1, what we have to do, we have to first read aij, that is what we have to read the corresponding coefficients of the variable. Next, for k equal to 1 to n minus 1 in steps of 1, 2. For I equal to k plus 1 to n steps of 1, 2. These are nested for loops. What we have to do, we have to find the value of u, that is aik divided by akk. Next, for j equal to k to n plus 1 in steps of 1, 2. aij, we need to find aij, that is aij is equal to aij minus ukj, and that's end of the second for and end of the corresponding first for. Backward substitution for finding values of x1, x2 up to xn. Here in this example we have taken the three simultaneous equations. So backward substitution means here by doing the above algorithm we will get the value of x3. So by putting the value of x3 in second equation we get the value of x2, and then by putting it value of x2 in the first equation we get x1. So this is basically a backward substitution. So by putting the value of n equal to 3 in this method, we can find we get the value of x3. Then for I equal to n minus 1 to 1 in steps of minus 1 to minus 1 is taken because we are going backward substitution. That's why it's taken as minus 1. Sum is initializes to 0. For loop is here for j equal to I plus 1 to n steps of 1. What we have to do, sum is equal to sum plus aij xj, and that's the end of the form. Next, xi is equal to ai n plus 1 minus sum divided by aii, and that's end of that formula. So this is the basis of the Gauss elimination method. I hope you understand it and implement it. Thank you.